Then let's also share screen so that those at home. I hope one of you can unmute to tell me, because otherwise I don't know what you're seeing, and I'm hoping you've seen a white sheet of paper. I do not see my chat when I'm like this. All right. So I'm going to functions compositions. Unless you need something discussed about transformation. Okay. So we are still on set 6. That's the reason why I extended it to Sunday. We had not finished the topic. If you have printed off the notes, we was working on slide 17. We left on Tuesday. All right. Are y'all feeling okay with the addition, subtraction, and multiplication of them? Okay. So the next slide, and I said we was going to pick up here anyway, is about the quotient of two functions. Starting out basic, which means they probably understand if you can't simplify this stuff. Suppose that the functions f and g are defined as following. F is parentheses x plus 5, x minus 1, and g of x is negative 6x plus 9, and bless you. We are asked to find f over g of negative 3, and then find all the values that are not in the domain. So this is slide number 18. We'll call this 18A. Again, my main function is f of x is x plus 5, x minus 1. And my g of x function is negative 6x plus 9. All right. In the first part of this, it says find f over g using a negative 3. So if you think what that's saying, it's saying put function f over function g, then plug in negative 3. So if I put f on top, which is parentheses, and x plus 5, and a parentheses, x minus 1. Notice I'm taking my little x's and making small parentheses with it. Over negative 6x plus 9. And I stuck in a negative 3 for all the x's. Well, what's negative 3 plus 5? What is negative 3 minus 1? So we've got a 2, a negative 4. What's negative 6 times negative 3? 18, and 18 plus 9. 27, and 2 times negative 4. And do y'all know of any reason that I can reduce negative 8 over 27? So for the part A, my answer would be, notice I can put in fractions because they give me the ability to. I put in negative 8 over 27. Part B. Again, instructions for part B. find all values that are not in the domain of f of g. If there's more than one value, separate them with commas. Okay, I got a fraction here. What can a fraction not have? And I have a denominator of 0. Now, also, I would ask you if I had one about square roots, because there's restrictions on square roots too. So 2 things you need to always check on your function. Do you have square roots? Do you have fractions? You've got 2 conditions. Remember, we only take square roots of numbers like 0 and greater. We cannot have fractions with denominators of 0. Case here then basically, since the denominator was negative 6x plus 9, solve that for 0. Y'all check my arithmetic. I'm with you. Good. Finds everything. So, in other words, we can use everything we want except 3 halves. 1.5 can't be used. What happens is it's probably hugging a line. But please think, unless you're going through 3 halves. That's probably what's happening if we graph. My next part of that, which is 18b. You're given that h of x is equal to negative 2x squared plus, sorry about that. Writing right over my other answer. Negative 2x squared plus 7. G of x is 4x minus 2. The function asked you in part A is find h over g of negative 4, folks. So at your desk, would you please work that part A? That looks like a 9 instead of a G down there. I apologize. It's sloppy sometimes. Feeling like my arithmetic's off. No? Oh. All right. Maybe it's gonna be a good night. Stay close to my son so it can wrap around me if the tornado comes. I'll protect her with that. All right. The denominator was 4x minus 2. For part B, you gotta set that equal to 0 and tell me what would cause it to be a 0 number. Okay. That better? I got 1/2. In other words, you couldn't use 1/2. Okay, so really quotient of functions is not that bad. You just got to remember there's some restrictions on domain. So if we had this in a word problem and we got 1/2 as an answer, we'd have to toss it out the door. Because it can't happen in life. That's not a solution that would fix the situation. It just make it work. Okay. All right, so slide 19 is our first combining functions advanced. Now this time, here's the difference. A while ago, we combined functions to work with. This time, we're combining functions and we're leaving the variable. We're not plugging it in. So, starting with this slide number 19, considering this A, we're given that f of x is negative 4x squared plus x, and g of x is equal to x plus 3. And in the first box here, we're asked to add f plus g, leaving x. I'm not saying this is easy, but don't try to make it tough. It simply states, take function f, add function g. So if f, and it might be right, first off, put them in parentheses, telling yourself what you're doing with them. Is there anything to restrict me from dropping these parentheses around the negative 4x squared plus x? Is there anything to cause me to keep from dropping the parentheses around the x plus 3? So if I drop the parentheses, is that the answer you're going to give? Why not? We've got some cleaning up to do. The official final answer of adding those two functions is that function. The only difference was what is that we added them, we took a number in for x. You'll read the next one. The second half of that same, there's another part of that box. Give them the domain. And you will be given it in interval notation. Okay. Ask yourself this. Did either function have a fraction? Did either function have square root in it? Which one has square root? That's x squared. Okay. Folks, that's the only two things that keeps you combined in chains. Otherwise, you can put whatever you want. We can put positive numbers in for F. We can put negative numbers in for F. We can put little zero in for F. We can put a fraction in if you want to. It's okay. I know I put one in, I don't want to do it. So since you have no restrictions, the domain to both F and G and F plus G was all real numbers that you put in as an interval from negative infinity to infinity. Again, two major things hit my mind with restrictions. Fractions and square root. Again, this was in one box. In the box underneath it, it says to take F times G of X. And then underneath it, it says also give that domain. Well, F times G. F was negative 4x squared plus x. G was x plus 3. How do y'all propose I multiply them? Pull it up. All right, so negative 4x squared times x would be negative 4x cubed. Are we okay? Negative 4x times 3 would be negative 12x squared. How we doing? X times x would be an x squared. I'm not adding x and x. I'm multiplying right now. And then x times 3 would be 3x. Y'all want to leave that as your answer? Because there's some cleaning up. How about negative 4x cubed minus 11x squared plus 3x? Can I go any further about cleaning them up? Why not? All different exponents. You can multiply them and they be different exponents, but you can't put them in the same field. Or opposites. Okay, again, did F or G or your F times G have a fraction? Did it have a square root in it? And do you have any restrictions? And it's all real numbers. Okay. I just need to put myself a little bit of notes. Sorry about that. I'll keep so many papers around. Get lost. All right. The second half of that one does have situation. So again, I'm on number 19 slide. I'm doing part B, which is on the right. And I've been given that function f of x equals x plus 4. That don't look bad, does it? But g of x is the square root of 2x minus 5. Before we even begin, let's see what the main restrictions before we even start with it. G's got some restrictions. The restriction is that our 2x minus 5 has to be greater than or equal to 0, or we can't take the square root of it. So if I add 5 to both sides, do you want me to flip the arrow because I added 5? Okay, so then I'm going to divide by 2. Do you want me to flip the arrow? So there's our restriction. We can only talk about x's greater than 5x. Right now. They may throw us another curveball. All right, so the question is asking us to take f and subtract g of x. So if I take f of x plus 4, excuse me, and I subtract the square root of 2x minus 5. Now, please note the square root symbol protects people under him. Okay? So the minus sign in front of that parentheses cannot go through the square root concrete steel wall. It just won't penetrate it. I'm sorry. You can try all you want. So simply x plus 4 minus the square root of 2x minus 5 would be your answer to this part. Again, I cannot throw the negative through the square root symbol. It's a concrete steel bomb shelter. I only see that one square root, which we've already dealt with. So I'm going to tell you that you already helped me find that the domain is from negative 5 half, from 5 halves to infinity, because it was greater than 5 halves or equal to 5 halves. It's positive, yeah. I said negative, and I caught myself when I said it too, and I said yes, it's positive 5 halves. What we can have. Everything greater than it can go, even 5 halves. 5 halves, and it just makes the square root of 0. What's the square root of 0? One, isn't it? But try to take the square root of a negative, and it's they don't know. They don't want them. They're leaving I for GPS. Honestly. The bottom half of that same question is asking you to do f over g of x. Okay, so if I put f over g do you think I can simplify any of that? Don't look like anything to clean up, does it? We got a quiz. You've got a fraction and we've got a square root. Now, you said the square root is greater than or equal to 0. As you said, I can take the square root of 0. Roughly, if I take the square root of 0 and 0 and he's underneath the fraction, guess what? I'm doing this with the class. I can't have a fraction with the denominator 0. The answer we just put has one little trick. Take the bracket, make it a 3. Because you can't use the 5 halves. The 5/2 is when you make the square root of 0. Square root of 0 is 0. That 0 is underneath. So the answer you had in this top part is fine. It's just that we cannot now include the 9/2 because that makes that denominator of 0. Sorry? I cannot have a bracket at all. Because if you put it in that square root, you're going to have a square root of 0, and the square root of 0 is 0, and 0 can't be underneath the fractional. That's what it would be. All right. The next one is composition of two functions basic. Now, you know, Miss Robinson, she gets really crazy sometimes. I call composition of functions doing a fog, a gog, a fog, and a gog. Okay. And I'm sorry, but it's very hard to get a composition symbol on your computer. All right. That raised open almost looks like a degree symbol, but it's not high enough. That is a symbol for composition. Okay. And this is where you wanted, Amanda, composition. So that raised, that little bit raised, open circle that looks like a degree, just not high enough, is called composition. Composition looks backwards. You plug in, you plug in. You're going. Come on, Miss Robinson. A little bit more explanation. This don't make sense. All right, we are on slide number 20. This happens to be the first one. I'm given the function, and I believe that's a q of x, which is 2x minus 3. They give me a function r, which is negative x minus 5. And they asked me in the first part of the box to do r composition q of negative 3. And then they're going to ask me to do an q composition of r with the negative 3. So this is two separate problems. Plug in backwards. Okay. Take negative 3. Here's your first step. Take negative 3 and plug it into function q and get me an answer. So do that at your take. Take negative 3, plug it into q. Here's the number. Don't touch all, just q. Yes, no, maybe? You think okay? All right. So you just plugged in the negative 3, you did its job, it spit it out. Negative 9. Bye-bye, negative 3. Hello, negative 9. Now you're going to take the negative 9 and you are going to plug him in to r. Take function r, Well, you just a negative 9. Because -3 5. He's been whooped. He's through with his shit. You have just positioned your first 2 functions. That is, we'll get there. Yes. So in this case, I'm going to start with -3, but I'm going to put it in R first and get an answer. And then we're going to put that answer into Q. So start with R first. Then take that answer, and I'm hoping I'm arithmetically correct, and put it into Q. I got a -2, by the way. No? Huh? Okay. And so if I put it into Q, which was 2 times that, -3. Final answer is -7. Just like in the factory. We put raw materials in, it gives us a part. That part gets taken to another machine to get me put in something bigger, right? You get a little electrical motor that runs the freon to our refrigerator. It gets sent to the refrigerator unit. Because mine's humming in the house, that's stuck to my brain. And the fact my husband used to work for Whirlpool way before I met, okay? That's a gentleman. There's not even a Whirlpool plant in Fort Smith anymore. Okay. So composition with numbers. Talk to me. Sound okay? Just take baby steps. As you was bringing up, you didn't like when it said composition of functions, advanced. I bet that's the advanced part. No really little numbers to walk through. All right, this is slide number 21. I have g of x function. Remember, that's just its name, okay? That's just its name. Don't mess with its name. What it does is x squared plus 1. That's what we got to mess with. And h of x, which is given to me as x squared plus 4. And we are to find the composition G, composition of H, and then specify the domain using interval notation. Okay. First off, before we start with it, does our function have a fraction? Does our functions have a square root? So we probably have no restrictions on them, do we? Our domain may end up to be all real numbers. So far, y'all haven't found the restriction for me. Okay. What this really means is you're going to take function G and in place of its X, you're going to put function H. Just another way to write what we're about to do. Okay. Miss Robinson, peer-building step. The first function listed is G. Would you write me function G? Don't write G of X, so just what's after the equal sign. And every time you come to X, I want a parenthesis. Hey, function G. Write it down. But when you come to an X, I want you to pull it apart into a set of parentheses. Guess who's going in the parentheses? Bingo. So inside that parentheses, I got to put X squared plus 4. Then I got to clean it up. Do not make me mad. I do not want to hear X to the 4th plus 16. I'm sorry, you take X squared plus 4 and you square it, you better give me 3 terms. I believe it's on record, but I don't go into the records. I don't want to go in the records. They don't have mine updated either. All right, so take X squared plus 4 and write it down twice. So X squared times X squared is X to the 4th. I didn't say it wasn't the answer. I'm saying you just didn't give me all of it. X squared times 4 times X squared. 4 times 4, and then the plus 1. So your composition, Miss Amanda, is X to the 4th plus 8X squared plus 17. You are plugging in, plug it in. It's just not enough. You're taking one function and you plugging it into the other. So you can get it. Okay, folks, did we end up with a fraction? Did we end up with the root? Then do we have any restrictions? Then all real numbers are domain. Yes, I'm sorry. That better? Negative infinity to infinity, no restrictions is our domain. Is that always the case? No. But when you're checking domain, go back to your original function and your composition both. Because they are there. All three, really. Number 22. I'd like to do it because as Miss Amanda brought up, this is a very big topic and one we want to do well. So today's date, 3/2/23. That's 6. And this is going to turn out to be my page 3. And 22, they gave me the function f of x is the square root of 3x plus 12. They give me g of x as x minus 1. Whoops, I didn't mean to put that parentheses yet. So do we have some restrictions before we even begin? Oh, yeah. We'll look at it in a moment, though. All right, our question in this particular one is they want us to do a fog. Remember, I exaggerate here, but F composite G. So I'm going to take function F and plug G in. So if we take function F, and in place of X, I make a parentheses. And y'all stick in the X minus 1 in parentheses. Can you clean this up? Yes, then let's clean up. 3x minus 3 plus 12. And I believe it's going to clean up as 3x plus 9. Okay. You told me we had a restriction at the beginning. Have we ended up with a function with a restriction? Yeah. Are they probably the same restriction? No. We've got to see where they overlap. This is one of those union situations. You got to create anything that makes either one of them. All right, so let's take this slope. In 3x plus 12, if it's got to be greater than or equal to 0, that's 3x is greater than or equal to negative 12. Y'all didn't want me flipped, did you? Divide by 3 means x is greater than or equal to negative 4. Didn't want me flipped, right? Okay, now that was back on the original function. Now you've got 3x plus 9 is greater than or equal to 0. So 3x is greater than or equal to negative 9. I'm sorry, thank you. So x is greater than or equal to negative 3. Okay, now let's think about this. Number line. You said I had to use numbers greater than negative 4. Number line. You say I have to use numbers that's greater than negative 3, and I said union, and I didn't mean union, I mean intersect. Oh, I mean union. What's not shaded? All of those that's less than negative 4. So that means, and I can't use negative, oh yeah, I can use. No, I cannot use negative 4. I can't even use negative 3.1. Guess why? It's not bigger than negative 3. So the only thing y'all can use in this problem, oh, negative 3 can have a bracket though. Because he is part of negative 4 shading, and it does have an equal part of that. There's your domain. It is intersection, not union. What they both have. So, talk to me about compositions. Makes it almost seem like I'm saying English composition class, doesn't it? So y'all have English comp 1 and 2, and math comp, algebra comp. Does that mean y'all gonna do them composition notebooks? You don't have to. All right. That is slide number 22. Using a graphing calculator to find loca extrema of a polynomial function. You need something. Guess what it says you gotta have? I have a calculator. This is not paper and pencil. About that, but it's not favorable. Alright, the polynomial function f is defined by f of x equals x cubed plus 2x squared minus 2x minus 3. Would you please take your calculator out, put it on under the y equals button? Would you please put that function in? By the way, you can either use the caret key in 3 or you can hit math 3 to get your cube on them. So again, under your y equals button of your graphing calculator, put in function f of x. Remember, f of x is your y. We're dancing today, by the way. For 2 seconds. Everybody okay with me? Just to be safe, would you hit the zoom button and number 6? I was just getting you back and standard window in case you didn't working with your calculator somehow and got it off. How's our graph compare? Oh, I could time mine up, right? It is a cube, right? Does it look like a snake? Yes. Another gram. Or not. The polynomial function is defined. Use the Alex graphing calculator to find all the points for where there is a local maxima. Round to the nearest hundredth. If there's more than one point, enter them using the AND button. Got it? Okay. That's an extrema. That is a maximum because that's when the graph is going from going up, coming down. We got to find that point, and we're going to use the calculator to do it. Because remember, they don't just want numbers like 3 and -8. They want it rounded to the nearest, is it 100th? Okay. Sorry about that. With my 2 students in Zoom. Okay, and y'all want this where you can read, watch it later, right? And if I write on the board, you can't see it. Okay. So the steps to finding a local extrema in the maximum area. Hit y equals put in function. Is that not what I made you do? Step 1. Okay. You're not all going to always hit Zoom 6, okay? But you could if you wanted to get it back to normal. Okay. 2, make sure to graph it. So if you don't hit Zoom 6, you're going to have to hit the graph. You're talking too fast. Hit the graph button. In this case, I would like you now to hit the button that says trace. When you do so, do you see a little flashing X? You probably set it on the Y-axis. That's not the answer. That's the Y-intercept. That's not what that is. Okay. use either the left or right arrow keys and move to top of that hump. You're trying to get your cursor right there. So I'm going to use the left arrow key. Do not use up and down. Do not use up and down. Move your cursor as close to the top as your eyesight will let you. It doesn't matter if you're not in the same spot I'm in. Are you open? Texas two-step time. Sorry, I don't sing. My accordion's in the accordion's still in the basement. I haven't found the accordion yet. It's still in the basement. I saw one Saturday, it was $80, and I'm sorry, it was in worse shape than mine. Mine did. I could get nice pretty money for mine. Okay. Anyway. What I need you to do now before we do the Texas two-step is I need you to hit second and trace. Do you have a menu that says value 0 or root? Intersect, does that look like the menu that's on your guy? What was we looking for? Ah. I want to hit the digit 4. Digit 4. Did you get a question at the bottom? Step here. Okay. So we chose. So step 6 would be choose max. You know which one they ask you. Okay. So when I said move to top, I could also said for bottom, because it's basically the same steps for minimum. Okay. Texas two-step. Please hit your left arrow key twice and enter. So twice, enter. Did you notice that your question changed? You noticed that there was a triangle put at the top of your graph grid? You just told the calculator, hey, don't look any further that direction. It's not there. You're going to confuse yourself. Now, arrow key 4 times and enter. Okay. Miss Robinson had just done a boo-boo, so she's going to correct it. I'm sorry. 2 to the left, 4 to the right. And then finally, oh, did you notice that it put a second triangle up there? Did you notice that the question changed again? Last Texas two-step that Miss Robinson would prefer doing, even though Texas Instrument argues with her over it. I want you to hit the left arrow key again twice and enter. And then we're ready to record our answer. So, ladies and gentlemen, and I'm sorry for y'all at home. What we did was 1, 2, 3. Now 10:01, 2, and everything. He gave you the coordinates of that point, sitting at the top of that hump. Now my calculator, that's the numbers that's at the bottom of my screen. So to the nearest. So it wants it as an order pair to the nearest 100. I do believe that's going to make it negative 1.72 and 1.27 to the nearest 100. Did our original graph have another hump? I only saw one mountain top. If it had another one, go back to where you hit trace. And start back up. Move it to the next hump. So students ask me very often, okay, do I need to start with the left or the right? It really doesn't matter. Since you read the graph from left to right, let's just start with the one on the left. Move to it, do the Texas two-step, get an answer, then hit trace, move it to the other one, do the Texas two-step. Get an answer. Choose the word and to put between them. So this one's asking you to find a local minimum. So would you please put that graph on your graphing calculator? And if you want to clear out that last one, just hit the clear button. Of course, to raise it to the fourth, you're going to have to use the caret key. We do not have a special place for that. And so that's what it looks like on my calculator as an equation. I'm sorry. And if I hit graph, now, if it asks you to find the maximum, there's only one. But do y'all see two minimum valleys? So again, it doesn't matter which order you find them. But before you can find it, you've got to hit trace and get there. You've got to hit your GPS trace, get to the location. Then you got to, what you're doing when you're doing the Texas two-step again, you're cutting off the screen so your calculator knows where you want to focus at. Because otherwise it's going to go haywire. Thinking, well, now I would have fun. Might have put something wrong. Oh, I think you put -9 instead of -9. That would do it. I'm surprised I saw that. Okay. I'm not going to walk you through it, but it's the same principle again. Just hit trace, move it there, do the Texas two-step, hit trace again, take it from the bottom one if you did it left first. I went too far, I think. Gotta watch my cursor. I got it off the screen so quickly. Then once you do the Texas two-step, hit trace again and then move it to the next valley. All right. We are slowly getting caught up, believe it or not. Topics, set 7 has a total of 17 topics. Lot of calculator. Lot of quadratics. So, kind of before we start this, let me remind you the quadratic function normally looks like this. AX squared plus BX plus C. Again, B and C could be negative numbers instead of positive. Even A could be negative. We have done the quadratic formula to solve it. We have factored it to solve it. We've used the square root method sometimes to solve it because it was a quantity squared equals quantity squared. Another form that we like to see quadratic functions be given to us in, because it's known as x minus h in it, x minus h squared plus k. Those signs have to be those signs, or otherwise you got negative value. That's not as vertex form. That helps us find the max or min of a quadratic fact. Your vertex in this case is HK, so you want the opposite of this number, but you want that one just like it is. Your vertex in this case, y'all remember the quadratic formula? Of the quadratic formula start with x equals negative b. The vertex starts out with the opposite of b being placed over 2a. That's the h. When you take that number and you plug it in, that becomes the k. That's your xy of the vertex. When it's given to you in standard quadratic formula. Looks like you're doing the quadratic formula. Not there yet. Y'all be safe this weekend. I can tell you already packing up on them. Linear regression is supposed to close at 3 for the regression. Remember, set 6 on Sunday, then get started on set 7. I had to shove it in again. Huh? There's just 9. Oh, okay.
Thank you for help yesterday.
You're welcome.
I believe this is from exam A.
Oh, okay, yes, because otherwise it's not
Yeah,
able to
Not have.
put a grade in Canvas.
Need to be a practice exam.
If you thinking there's just a typo and need some more points off of it, because remember, if you're taking it twice, I'll take the best grade,
Practice
10%.
exam was. Actually, I think it was.
If you took it twice, I'll take 10% of the best score.
I'll just give it to you in case I did.
I don't blame you. Because sometimes it's just a typo, or you can even get partial credit that I do not have Alex set up to give on quizzes or tests at the moment. I rather check than get hard, yes. I'm looking for Sarah P. Yes. All right.
Oh, sorry.
All right. Let's put that in.
Here.
Okay. Got your name on it. Good.
One set of problems on there.
All right.
Thank you.
You're welcome.